Adam Ree, the physics Nobel laureate, recently acknowledged that we still don't fully understand the universe. He claims that a perplexing discovery made by the James Webb telescope demonstrates once more that the universe does not behaving as our models would have us believe. However, how is it possible that the cosmos is expanding at a significantly quicker rate than our current model permits? For a long time, specialists have been facing significant challenges due to the so-called Hubble tension. Scientists at the universities of Bonn and St. Andrews, however, think they have finally figured out how fast the cosmos is expanding. There is still one important catch to their innovative strategy, though. Only if we reject Albert Einstein's theories on the nature of gravity will it operate. We'll show you today what Webb has revealed about the farthest reaches of space and how this fascinating alternative idea resolves one of the biggest riddles in study history. Less than 3 years have passed since the start of Webb's scientific mission, yet already the most potent space telescope ever constructed has managed to upend our conception of cosmic development. The Webb has now discovered a whole series of enigmatic galaxies that seem much too big and massive for their age, which is only a few hundred million years after the Big Bang, as any person who is even mildly interested in the topic will have noticed. They soon gained the notorious moniker universe breakers, since the existence of these early galactic giants cannot be explained by our present models. However, is this nickname truly fitting? Who knows, though? Because it's possible that the situation is not as dire as first thought. Indeed, a recent study has concluded that the enigmatic red objects are actually expanding black holes rather than bizarrely large galaxies. Furthermore, we are no longer faced with galactic premature babies that make our conventional model of cosmology fall apart like a house of cards, where the majority of the measured light is caused by such strange mass monsters. And we currently appear to be headed in the correct direction, even though the solution necessitates more follow-up observations. Regretfully, however, this does not apply to another, equally important issue in the present investigation. The cosmos is expanding, far more quickly than our theoretical projections permit, as was briefly stated at the beginning. One Edwin Hubble, who discovered around a century ago that the Milky Way is not the only galaxy in the universe and that other galaxies are also moving away from us, is responsible for our knowledge that the universe is expanding at all. But, along with this remarkable discovery came the equally revolutionary conclusion that, when viewed in reverse, the spatially expanding cosmos must have had a tiny beginning point where everything was once compressed. Furthermore, experts in the 1990s found that space is not just growing, even if that initial point has since come to be regarded as the original singularity, which now serves as the foundation of the Big Bang theory. In fact, it is expanding, faster than anyone could have predicted. Once more, dark energy, an equally enigmatic and unknown force that is supposed to resist gravity, was proposed as the cause of this perplexing acceleration. However, what is the precise rate of expansion of the universe? This banal question may seem like it can be resolved fast, but it's actually at the core of a research conundrum that astronomers have been attempting to solve for years. Why is the Hubble tension such an issue? From a theoretical perspective, the issue appears to be straightforward. The Hubble constant, which measures how quickly the universe is expanding right now, is approximately 67 km/s per megapark if we calculate it using the standard model. Although the unit may seem a little odd, considering that a megaparsec is equal to about 3.226 million light-years, this essentially means that galaxies are moving away from one another in space at a rate of 67 km/s every 3.26 million light-years, or 244,000 km/h per megaparsec. Regretfully, this is only true on paper. Our direct space measurements have demonstrated that the Hubble constant is substantially higher in reality. In fact, it is 73 kHz per megaparsec, according to research, on red giants, supernovae, gravitational lenses, and variable stars. With an astounding 264,000 kWh, That represents a departure of at least 20,000 QUID from the theoretically expected number. The Hubble tension is a summary of this extreme divergence. However, what explanation is there? Could it be that the actual value of the Hubble constant was warped by significant measurement errors we made in the past? That's precisely what the academics aimed to discover when they re-examined the Hubble telescope data using the Webb. In order to accomplish this, the group from Johns Hopkins University in Baltimore, led by Nobel Prize laureate Adam Ree, examined variable stars, red giants, and a class of carbon-rich massive stars in greater detail. They finally discovered that the startling difference between theory and reality still exists. Consequently, an overall measurement value of 72.66 km/s per megaparak was also obtained from the study of the most extensive Webb data set to date. Therefore, measurement uncertainties or Hubble telescope mistakes cannot be blamed for the variations from the conventional model. Adam Ree also categorized his findings in the following ways: the disparity between the standard model's predictions and the universe's actual expansion pace raises the possibility that our knowledge of the cosmos is lacking. Discrepancies in the Hubble constant are a severe issue, especially when two NASA flagship telescopes are validating each other's findings. However, what might be causing this? In other words, if we don't fully grasp the cosmos, what have we missed up to this point? According to Ree, it might be a new kind of particle or field, an unusual form of dark energy or dark matter, or a mistake in our knowledge of gravity. Was Einstein mistaken? The Hubble tension's solution. Speaking of a mistake in our knowledge of gravity, the study team from the universities of Bonn and St. Andrews suggests that gravity may function far differently than is commonly thought, which would allow us to finally unravel the enigma of the Hubble tension. The approach, to put it simply, is predicated on the idea that the Milky Way is situated in a gigantic void, that is, a vast, empty region in the universe. According to extensive studies, the greatest connected structures in the universe are organized in a network-like structure whose grid forms the so-called filaments, rather than being disorganized and dispersed randomly. These filaments span enormous, nearly matterless bubbles along with the emptiness. According to a study headed by Sergei Mazareno, our Milky Way is likewise situated within a bubble of this kind, and, given this, it is able to quickly explain the origin of the Hubble tension. The researchers use the example of an air bubble baked into a cake to demonstrate this. Additionally, gravitational forces emerge from the bubble, drawing the galaxies inside towards the bubble's edge since the matter density surrounding the bubble is subsequently much higher. For the puzzle of expansion. This indicates that the galaxies are experiencing the impacts of a local underdensity, which is causing them to move away from us far more quickly than anticipated. Unfortunately, there is a significant drawback to this seemingly reasonable strategy. In theory, there shouldn't be any supervoids or underdensities of this kind. According to the standard model, matter should be spread uniformly throughout space. But according to the study's authors, a group of galaxies 600 million light-years away are accelerating 4 times faster than the mainstream model predicts. That's not all, though. In the same sentence, the scientists stress that Einstein's idea of the nature of gravity is the foundation of the standard model, and that it is possible that the man who developed the theory of relativity was mistaken on some important aspects. More precisely, this is the belief that gravitational forces act in a significantly different way than Einstein anticipated. As a result, the researchers' computer simulation also made use of a modified theory of gravity. This is specifically the so-called modified Newtonian dynamics, or MOND for short, which is actually regarded as an outsider theory that was put forth by Israeli physicist Mordechai Megrim in the 1980s. MOM does not even need the influence of the menacing dark energy to explain the spinning behavior of galaxies because it uses changes to the equations of motion of matter in the gravitational field. Big, empty bubbles in space are also predicted under the alternative theory, though. And that's exactly the point. If gravity acts as McGrim predicts, the universe's expansion rate would only have one constant, and the observed differences would just be the result of an unequal distribution of matter. The degree to which man will be able to overcome its outsider position in the future is obviously a different matter. We would have to give up some long-held fundamental beliefs about the nature of gravity after all. Additionally, we would like to encourage you to click the subscribe button before we have to say goodbye. Join our community right now to ensure you never miss another post from us. See you shortly.